And why don't you pronounce your team name?
Wir sind die Freiheitskämpfer von dem Deutschen Haus bei MIT. We're the freedom fighters, and we all live in German House.
And also, can you introduce your team names and explain your robots?
Our robot's name is Arnold, after the Terminator. I'm Ted, that's Melody, that's Jason, and Ben. And
your robot has giant wheels. Can you talk about that a little?
yeah, actually there are anti-gravity devices, which most people mistake for wheels. But it gives our robot about twice the maximum speed of pretty much all the other robots. I'm pretty sure we're the fastest robot in MathLab this year.
So, do you think that speed gives you an advantage?
Yes. I mean, a lot of our code is based on getting from one place to another by both wall following and random directions and speeds for random numbers of times. We also, but actually a really cool part of our robot is the ball launching mechanism. We cannibalized two printers and got a big motor in there that actually launches the balls out. There are two tubes that are parallel to each other in which we can store up to 6 balls. And there are gates that are controlled by a servo that we modified to turn infinitely. Those gates in front can open and shut depending on whether we're trying to get balls out or trying to get them in or trying to keep them in.
So, it looks like it's stuck. Will it time out?
There are several methods that it uses to get stuck if it escapes. First, it looks at the last few frames of the camera, and if they're the same, then it knows it's stuck, and it goes into the escape function. Also, we have 3 IR sensors on the front that detect if we detect that somebody's close enough. This really shouldn't be happening. I don't know what's going on. This is emergent behavior here. Okay, here it is. Yeah, there's several methods. It'll back up and spin around and turn random numbers of times. So it uses both a sort of deterministic and a random approach to escaping. Actually, the coolest part of our programming is the goal searching, because we use the images that we got of the goal to determine the distance we are from the goal, and also the angle that the goal is towards us, like if we're perpendicular from the goal or not. If that angle, we move to get that angle within a certain tolerance. I have no idea what it's doing at the moment.
So, I know you have a fairly unusual way of pushing the balls out from your cavity. Can you explain that?
Yeah, we took, as I said earlier, we took 2 printers and attached them to the motor with a belt. And we ramped up the acceleration constant and the voltage that it can use. Not the voltage, but the amperage. And so what we do is we actually sort of shoot the balls out. We get them. And during testing, we actually shot the balls out 10 feet once. It varies depending on how many we have in there, but.
So did you always think this was a good design, or?
What's that supposed to mean?
I was alluding to the fact that many people have told Ted's team that their ball delivery system in particular would not be a good idea. I don't know if you want to talk about that.
I don't remember anybody saying that. Oh, well, we were worried about it jamming because it has 2 rods next to each other with something in between them that slides, which isn't really ideal. It would be much better to have one rod and the center of force be on the same axis as the center of the friction. But we put enough WD-40 on there to kill some people. So, and we actually haven't had any problems with that. We were expecting lots of problems, but what we have had problems with is the the reliability of the ball getting coded, as you can see. And also, we've had some problems with the gate in front because the servo can get stuck if the gates get stuck, and it can mess up some things. Bis zum Hinterhand.